Hello, in this video I'm talking about standard form and specifically for really big numbers. I'll do another video where I deal with the other end having really small numbers. And the idea of standard form is if you have these really big numbers with loads and loads of zeros, and some of them are ridiculous, like Avogadro's constant has something like 24 digits to it. You can't be, writing out, 6, 2, 3, 0, 0, 0, 0, 0, and then sort of you got to count and keep track of how many digits you're up to, and then the poor chap who has to come and read it after you has to then carefully count up and read it. And so when you're dealing with these really big numbers, it's really unhelpful to write them out as big numbers. It's better if you could just say what the important bit of the number is, the bit at the beginning, because let's face it, if we're measuring something really big like this, if it's a really big distance, then do we care sort of, the accuracy down to the 24th digit? No, of course not. We care about the beginning of the number. And so we need those numbers, and we need to know how many digits it is, because if there was another digit on the end, it would be 10 times bigger, so that makes a big difference. But we can condense this down and say, okay, well, if we always put the decimal point after the first digit, specifically the first non-zero digit, although for large numbers that will always be the case, first digit, then the decimal point, so there's the important bit, and then we can say, okay, and so we don't count that first one because we've left that there. How many places does this need to move to make it this number again? Well, from here it would have to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 places. And if you times that number 6.23 by 10 23 times, then you will get back to the original number. So this is a way of writing out that big long number in a much more friendly way of writing it and reading it. We can see the important bit and we can see how big the number is. And it's not just about having a nice condensed way of writing it. It's also handy for comparing it, because if we had another really big number that was maybe 2, 4, 3 and then loads and loads of O's, you'd have to count up carefully to see, is this number a bigger number than that one? Count all the zeros. But if you've got it in standard form, 2.43 times 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I've had to count that, but when it's written down like this, you can instantly look and go, oh, well, look, no, this one is so much bigger. This has got, an extra 9 zeros on the end. This is by far the bigger number, and this one is much smaller. And so it allows you just to make comparisons. So even numbers that you wouldn't bother to write in standard form, if everything else is in standard form, you would also put in standard form. So even something like, the number 14, you can write as 1.4 times 10 to the 1. And okay, that seems silly to do that, but if you've got a big list of standard form numbers, you might do that so that you can just look at the powers on the tens and say, yeah, that's a really big number, big power of 10, that's really small. And then if you've got two with the same power of 10, you can just compare the actual numbers to see which one's bigger and which one's smaller. So let's have a quick look at these numbers we've got here and see if we can write these in standard form. And I'm sure the answer will be yes. So the key thing, the way standard form works, is it has to have a number to begin with that's somewhere between 1 and 9. It can't be a 2-digit number and it can't be 0. It has to be between 1 and 9 inclusive. So you put the point after that first digit, 7.58. And then you've just got to work out how far that decimal place has moved so that we can move it back when we need to. So times 10, and how many times do we times by 10? 1, 2, 3, 4, 5, 6, 7. So this is 7.58 times 10 to the 7. And likewise, this one, we put the decimal point after the first digit. So it's 8.785. times 10, and then we need to count them up. And often what they'll do is they'll group things in threes, so it's easier to count. So you can see 3 and then there's a little space. People used to put commas, but we don't do that anymore, because if I put 1296 down with a comma to show 3 digits, and there's a little gap, people in on continental Europe use a comma as a decimal point, so they would read that as 1.296, whereas I read it as 1296, which is quite a big difference, really. So we don't do that anymore to stop that confusion. We just leave a little space bar like they have here, so it's easy to count 3, 6, 9, 10, 11 places, so we put the power of 11 there. Likewise, you can write them out in full. If they ask you, or could you write this out in full, then you just put the important numbers down and then count 6 places from the decimal point here. 1, 2, 3 to clear the numbers, 4, 5, 6 by adding zeros. And same thing here. Well, this time it's 3 places it's going to move, get bigger by 3 decimal places, so 1, 2, 3. All it does is clear the numbers, so it's just the number 3, 5, 6, 5, and that's it. Now there's a few things that you might be asked to do with these numbers other than just convert them in and out. You might be asked to add numbers together, for example. Maybe not numbers like this, but maybe if we change this to times 10 to the 6, then you might be asked to add these numbers together, and you can do that on your calculator. The calculator has a times 10 button. Let me just shrink that down slightly so it fits on the screen. It has this times 10 to the power of x button here. It's really important that you use that. You could type it all in like this, 7.58 times 10 to the power of 7, and it will see that number exactly as it is. That is what you're doing. But the calculator sees this as two things. It sees 7.58 and 10 to the power of 7, and you just happen to be timesing them together. Whereas if you type in 7.58 and use the times 10 button, you get this weird little times 10, and when you write the 7, it does it as a big 7, not a power. So it doesn't look as good, but the calculator sees this thing as one number, okay, rather than a number times a number of 10, power of 10. This sees that as one number that you've just written in a different form. And it's really important that you use that button because it can go wrong, especially when you do divided by. If you divide a standard form number by another standard form number, you can get the wrong answer if you type it in with times 10 to the power instead of using the times 10 button. So as I say, you can just type these in and work them out on the calculator, but there's a good chance that you'll be told that you're not allowed to use a calculator. So just before we do this, let's have a look at how we would do this without a calculator. Now you could, if you were being long-winded, you could write this out as the big old number with lots of zeros and this one out with lots of zeros, but it's not the best of ideas because you can make mistakes counting all those zeros. That's the whole point of having it with the powers, is it stops you having to count. So why would we then write it out and count and run that risk? So instead what we'll do is we'll just amend one of them into the other. So if we say, okay, well, let's make this have the same power of 10, and then the decimal points will line up. So if we change this up to 7, if we make that bigger, well, I've made this whole number 10 times bigger now, so I best make this 10 times smaller and change it to 0.8785. And now they've both got the same power of 10, I can just add them together straight away because I know that those two decimal points are both 7 places away from where they should be, so they line up. So I can just do 7 add 0. Oh, I shouldn't do it from that end, should I? I should do it from the other end. So 0 plus 5 is 5. 8 and 8 is 6, carry the 1. 5 and 7 is... Wait. I should have rewritten it, really, because I'm adding that up all wrong. So let's rewrite it lined up. 0.8785. I've got 2 clear that I've got to make. So that was all wrong. So let's try it again. 0 plus 5 is 5. 0 plus 8 is 8. 8 and 7 is 15. 5, 8, and a 1. So that's going to be 9, and that gives 14. And then 7 and 0 and 1 is 8. So we've got 8.4585 times 10 to the 7. And we can just check that that's right. 84585 If we count it back, 1, 2, 3, 4, 5, 6, 7. Yes. So it's giving me the same answer. Now, it's really important in a test that if it asks for your answer in standard form, you give it in standard form, and you might find that if you do it on the calculator, it doesn't give you the standard form, and you write that down, you lose the marks because they've asked for standard form, so just be careful. And if you ever get an answer that's not in standard form, but it asks for it, again, you can just augment it like I just did there. If you've got something like 23.47 times 10 to the 11, and it asks for standard, give your answer in standard form, and this comes out as the answer, well, this is not in standard form because the decimal place should be after the 2. So same thing, if you move that decimal place to make it smaller, if you move it to here, you've made this number smaller. Okay, 3 times smaller. If it 3 times smaller, 10 times smaller, it's because that was a 3 there. 10 times smaller because it's moved one place. If it moved more places, it would be 10, 100,000, yeah, however many places. And because I've made this number smaller, to keep the whole thing the same size, I need to make this bigger. So make that up to a 12. So there's quite a lot of things there. The key thing is converting between them, counting the places, writing it in the standard form where it's much easier to pull out that information, and of course getting it back by counting that decimal place back that many places. If you are asked to add or subtract them, or times and divide, then you can, adding and subtracting, you need to make the times 10s the same, the powers the same, so that you can line up the decimal places. Make sure you do that properly. And then you can just add it, and then augment it back by, if you make this smaller or bigger, then you do the opposite to the power to balance it out. If you are timesing and dividing, it's slightly different. If you are doing a times and divide, then it's not too bad, because 8 times 10 to the 3 times 4 times 10 to the 2, for example. 8 times 4 is 32. 10 to the 3 times 10 to the 2. When you times the same base with powers, you add the powers. So it's 32 times 10 to the 5. But of course, that's not in standard form. So you have to make this smaller, 3.2, and then make that bigger, 10 to the 6. I'll leave it there. If you have any questions, then you can pop them in the comments down below. But for now, cheerio.